Hello friends. So up to now we have discussed about the what is the organic semiconductor, what is the importance of the organic semiconductor and its advantage, disadvantages, and how the electron can transport through the organic semiconductor. All other the transport mechanism we have discussed till now, right? So during the first or second lectures I have discussed about the what kind of the devices we can make by using the organic semiconductor, right? So now I am going to discuss about the one of the device that is a popular device which can be designed by organic semiconductor, right? So the name of the device is the organic light emitting diode. Organic light emitting diode. The full short form of the device is the OLED. Okay. So organic light emitting diode. This is one of the most common devices in organic optoelectronic area, right? So organic light emitting diode. So first today in today's class I'll discuss about the introduction of the organic light emitting diode, and followed by the types of the organic light emitting diode and working principle of the organic light emitting diode, right? So organic light emitting diode, it has emerging application in the light and display technology, right? It has various application in the lighting and display technology, right? So the performance of the organic light emitting diode, it is continuously developing, and the organic light emitting diode, it is already commercialized for marketing purpose. Okay, we can see different kind of the organic light emitting device like display, right? OLED TV. We have the OLED TV that is already commercialized, right? So now, so why it is so much important, why we can use this organic light emitting diode? Okay, so main important is that the organic light emitting diode, this is one of the name of this organic light emitting diode is the energy saving device with a very low cost, right? It is a energy saving device with low cost. Okay, now this device is most eco-friendly device. Most eco-friendly device means we can integrate the organic light emitting diode in various integrated circuit. Okay, so that is the most eco-friendly, and we can easily use for display technology because it is very thin and very lightweight. Okay, it is very thin and very lightweight, very thin and lightweight. Okay, due to this nature we can easily use for display technology, and it has low manufacturing cost. Right, now I am coming to the some electrical parameters or electrical properties, right? What are the main electrical and optical properties in this organic light emitting diode? So light emitting diode means we have to emit the light and we have to get the high efficiency light output. Okay, so it has, okay, large emitting light emitting capability, okay, and wide viewing angle. Wide viewing angle means, so if we design the organic light emitting device, so we can view from the different angle. Okay, that is the wide viewing angle. Okay, high contrast ratio, okay, long lifetime, high response time, and the efficiency as compared to the normal inorganic light emitting diode. Okay, so already some response we got which is comparable and which is better than the inorganic light emitting diode. Okay, another most important feature, that is the flexibility. Okay, flexibility. So as the organic material, it has the one of the advantages, that is the flexibility. So we can design flexible organic light emitting display. Okay, that means this, suppose this can be the flexible. That means we can design the substrate over which we can deposit different kind of the layers, okay, for designing the organic light emitting diode. So we can use the flexible substrate. That means if we want to design the light emitting diode and the smart watch, so for this kind of the devices we can use the flexible display. So for flexible display, so we can easily use the organic light emitting diode, right? So these are the main features for organic light emitting diode. There are lots of features, so I have just focused on the main features, right? So how can you design the organic light emitting diode? Okay, so I'll just discuss about the simple structure. Okay, basic structure. Okay, suppose this is a okay. This organic light emitter, that is also consist of the solid state device which containing organic semiconductor based devices, mainly devices, right? So this organic light emitter, this is also called as a organic electroluminescence device. Okay. Oh, sorry. So organic electroluminescence devices, right? So this organic electroluminescence device, this consists of organic layer. Okay. So now suppose you can consider the three layer. Okay, three vertical which is deposited on top of the other layer. Okay. Suppose this is the electrode 1. This is electrode 2. So the organic layer, you can use the multiple organic semiconductor layers. So suppose I have considered only one organic semiconductor layer. So this organic semiconductor layer, this is sandwiched between the electrode 1 and electrode 2. So electrode 1 and electrode 2, this we can use by employing, this we can design by employing the metallic layer. Okay, different kind of the metallic layer is there. So but one of the electrode, okay, that should be transparent. Suppose this electrode should be transparent. Okay, light will be generated inside the device and that will be emitted from this electrode layer. Okay, this is the structure. Now, so enter the working principle of the organic light emitting diode, that is mainly depending on the light generating mechanism. Okay, light generation mechanism, right? So that means we should get the light, or the light should be emitted from this device. So because I have told that the organic lighting diode, that is used for lighting application. Okay, so by implementing different kind of the injection mechanism, different kind of the mechanism, we have to produce the light from the device. Okay, so that means it is totally depending on the light generating mechanism. Okay, so now I'll briefly discuss about the light generating mechanism. Okay, the light generating mechanism, that is applicable for inorganic LED or organic LED. Okay, so there are the various light generating mechanism. So under this main mechanism is the luminescence. Luminance mechanism means, so we have to produce the light, okay, by absorption of the optical energy or the electrical energy. Okay, luminescence, that means we have to produce the light or optical energy. Okay, we have to, so the output of this device, that should be optical in form, and the input of this device, that either optical or it may be electrical. Okay, that means the total mechanism, so we have to get the optical energy or light, okay, from optical energy or electrical energy. Okay, based on this, the optical energy and electrical energy luminance mechanism, that is divided into two parts. Okay, first one is the fluorescent mechanism. Next is the phosphorescent mechanism. Okay, so what is the fluorescent mechanism? Both are almost same. Okay, fluorescent mechanism and the phosphorescence mechanism, these are under mainly the photoluminescence mechanism. And the electrical energy. Okay, so here I told that, so luminescence mechanism. Okay, how can you get the optical energy from by using the luminescence mechanism? So what are the inputs? Inputs either optical energy or electrical energy. Okay, if we are giving the optical energy, that means the photoluminescence. Photoluminescence, that is further divided into the fluorescence and the phosphorescent mechanism. Okay, the electrical energy, that is related to the electroluminescence. Okay, now here fluorescent, right? That means in this mechanism, this is under the photoluminescence. Okay, this is under the photoluminescence. In photoluminescence case, the input will be optical energy and the output will be also optical energy. Okay, so that photoluminescence, that is further divided into the two parts. One is the fluorescence and another is the phosphorescence. So now I am drawing the diagram. Okay, this is the lower energy state S0, this is the higher energy state. Okay, S1. And okay, now suppose, so electron will go from this S0 to S1 by absorption of the photon. Okay, here I told that the input energy, that is the optical energy. So for absorbing photon, the EH nu, that should be greater than EG. Okay, EG is the band gap between these two energy level, and EH nu is the which optical energy you are sending to the system. Okay, the EH nu, that should be greater than EG, so that the system can absorb photon. Okay, by absorbing photon, the electron will go from S0 to S1. Okay, is the higher energy level. Okay, after a certain time, the process is the very fast process. So very quickly the electron will fall down to the ground state. Okay, and then emit the light. Okay, the process is the very fast process. The time duration, time limit for occurring this process, that is the picosecond to nanosecond. Okay, in this mechanism, very quickly electron will go to the higher state, and within a picosecond to nanosecond, that electron will fall down to the ground state to emit the light. That is the fluorescent mechanism. Now I will discuss about the phosphorescent mechanism. Okay, in this phosphorescent mechanism, there is a intermediate state in between S0 and S1. Okay, there is a intermediate state, suppose intermediate state in between S1 and S2, S0. Okay, now due to the some spin orbit coupling, okay, so electron will not directly fall down to ground state, from upper state to ground state. That will not happen. Okay, due to some other mechanism and spin orbit coupling, there is a intercrossing transition. Okay, electron will first go to this intermediate state. Okay, very fast. This process is also very fast, but it will take some time to move into the ground state. Okay, so first it will the electron will go from the S1 to intermediate state. Okay, so due to the intersystem crossing, and then intermediate state to ground state. Okay, so this entire process will take microsecond to thousand second. Okay, so this is the slow process as compared to the fluorescent mechanism. Okay, these two mechanisms mechanisms are available under the photoluminescence. Okay, so by absorbing photon, we will get the light. Okay, into various ways. Next is the electroluminescence. So in order to design the organic light emitting diode, mainly electroluminescence mechanism is used. Okay, electroluminescence. Electroluminescence means, photoluminescence means we are applying the optical signal to get light. Okay, so in case of the electroluminescence, we have to apply the electrical signal to get the light. Okay, so here my input signal is the electrical signal. Suppose this is a device. One is a p-type semiconductor, another is the n-type semiconductor. Okay. N-type semiconductor. Okay. So we have to inject electron and hole. So under the equilibrium condition, there will be no free electrons and holes. Okay. By applying the forward bias, we have to inject electrons and holes. Okay, and holes. Okay, you have to inject electron and holes inside the device. Okay, so after a certain time, when we will get the lots of electron and holes, lots of free electrons and holes inside the device, then what will happen? The electron will fall down to the ground state and it will recombine with the hole. This electron will fall down to the ground state and recombine with the hole. At that moment, it will emit the light. Okay, so when we will get at a certain place, so there is a accumulation of the electron and hole. Okay, due to the accumulation, the electron will directly fall into the ground state and recombine with the hole. So that phenomena will happen by applying the forward bias and we will get the light. So that means by applying the electrical current or forwarding bias, we will get the light, that is electroluminescence. So this mechanism is used for developing organic light emitting diode. So next class I will discuss about the structure of the organic light emitting diode and how it will work and what are the types of the organic light emitting diode. Thank you.